Hey everyone. So, you know how we've gotten really good at making AIs that can talk, write, even whip up some crazy images? Well, that's just the beginning. Something huge is happening right now. We're seeing a shift, a massive one, from AIs that are basically puppets, just responding to our commands, to AIs that are becoming protagonists. The main characters in their own stories, actually taking action. So, what on earth does that actually look like? Right. For what feels like ages, the whole game has been about perfecting these large language models, right? Training them to spit out the perfect answer to a single prompt. But that's starting to feel a little limited. The really big question we're tackling now, the one that changes everything, is this. What happens when these models stop just talking and start, doing? And that question brings us right here to a completely new way of thinking about AI. AI that actually acts. And look, we're not just talking about generating a block of text anymore. No way. We're talking about models that can genuinely interact with the world, use tools, and chase after goals over like a whole bunch of steps. So the engine driving this whole revolution has a name. It's called Agentic Reinforcement Learning, or Agent RL for short. Now, forget about just writing a perfect poem or an email. This is a whole different ballgame. It's the recipe for turning a language model into an actual agent. Think of an agent as a digital problem solver. It's a goal-oriented decision maker that learns by doing, and it uses feedback from its environment to constantly get smarter. Okay, to really get why this is such a game changer, you've got to see where we came from. So let's do a quick showdown, the old way versus the new way. All right, so the old way, and look, it's still super common, is something called preference-based RL fine-tuning. It's pretty straightforward, really. You give the AI a prompt, it gives you a couple of answers. A human comes along and says, yep, I like that one the best. And the model learns, okay, I should make more answers like that one. See? It's a one and done deal. The AI is literally a puppet trained to do one specific trick perfectly, right on command. Now, this table really lays it all out, the stark difference between the two. On the left, with the old way, everything is, well, static. The whole universe is just that one prompt. The goal, one good answer. The reward, a single score. But then you look at Agentic RL on the right, and everything is dynamic. The world is constantly changing with every single action the AI takes. The feedback isn't a one-time thing, it's step by step. And the objective? Oh, it's not just about getting one answer right. It's about actually achieving a long-term goal. So that's the absolute core of it, right there. We are making a fundamental leap from a static, single-shot task to a dynamic, multi-step adventure. The AI is no longer just a puppet sitting there waiting for us to pull its strings. No, it is now the protagonist of its own story, out there exploring its world and making its own decisions to get to the finish line. Okay, so if we're going to turn our AI into this protagonist, what does it actually need? What's in the toolbox? Let's break down the core abilities that make a language model a true agent. It all boils down to this basic loop you see here. Right in the middle, you've got the agentic LLM, our hero. It takes an action out in the environment. That could be the internet, a chunk of code, whatever. Then the environment responds with a reward, basically feedback. Was that good? Was that bad? And the agent uses that feedback to learn. But to make this loop actually work, to make it effective, the agent needs a few absolutely critical skills. First on the list, planning. A real agent can't just wing it. It has to be able to look at a big, messy goal and break it down into smaller, bite-sized steps. It has to think ahead. And then there's tool use. This is huge. The agent isn't just trapped inside its own code. It can reach out and use external tools, think search engines, calculators, code interpreters, to actually get stuff done in the real world. Next up, you absolutely need memory. I mean, if you're on a multi-step journey, you have to remember where you've been, right? The agent needs to keep track of what it's done and what it's learned so far. And finally, maybe the most important piece of the puzzle, self-improvement. This is where the magic of reinforcement learning really happens. The agent looks back at what it did, learns from its mistakes, and actively changes its strategy to be better the next time around. All right, this is all cool in theory, but is this stuff actually out there? Is it real? You bet it is. Let's take a look at some of these agents out in the wild. And the speed of progress here is just wild. I mean, look at this timeline. This shows the evolution of just one of those abilities we talked about, tool use. We went from the early days with frameworks like React, which was all about teaching models to think and then act, to these crazy advanced models like OpenAI's o3 in just a couple of years. The pace is absolutely staggering. And these skills are being put to work in some seriously tricky areas. We're talking about agents for search and research that can just Go. They'll browse the web all on their own, read a dozen pages, and come back with a synthesized report for you. Then you have coding agents. And I don't mean just writing one little function. No, these can take on whole software projects, writing code, finding bugs, and fixing them. And yeah, we've even got agents digging into math and science, using tools to crunch numbers and even check mathematical proofs. But of course, it's not all sunshine and rainbows. Building these super powerful autonomous agents, well, it opens up a whole new can of worms. Let's talk about the challenges on the road ahead. And really, the big one, the number one challenge that the researchers who wrote this paper are flagging is trustworthiness. Think about it. When you let an AI act on its own, when you hand over the keys, you have to be 100% sure that it's going to be safe, that it's going to be reliable, and that it won't be easily tricked. And trustworthiness isn't just one thing. It breaks down into a few really gnarly problems. First, you've got security. An agent that's browsing the web could land on a malicious site and get tricked into doing something bad. This is called indirect prompt injection. Then there's hallucination. If you only reward the agent for getting the final answer right, it might just make up a bunch of confident-sounding but totally wrong steps to get there. And then there's this weird one, sycophancy. The agent might figure out that the easiest way to get a good score is to just agree with whatever the user says, even if the user is completely wrong. It becomes a digital yes man. And on top of all the trust issues, there's just the brute force challenge of scale. I mean, the amount of computing power needed to train these things is astronomical. It's insane. And it's not just about the computers. You can't just feed them a bunch of text files. They need complex, dynamic worlds to learn it, virtual playgrounds that are constantly changing. And building and running those, that's a massive challenge all by itself. Whew, okay, I know that was a lot. Is your brain starting to feel a little bit bigger? I hope so. Hey, if you like these kinds of deep dives that, hopefully don't make you want to completely reboot your own brain, then you know the drill. Go ahead and smash that subscribe button for Vibe Doc. Seriously, don't make us send one of these new reinforcement learning agents to optimize you for it. So I'll just leave you with this one last question to chew on. As these AIs keep evolving from simple puppets into complex protagonists, are we writing the script for a powerful new partner to help us solve the world's biggest problems, or are we scripting an unpredictable new rival? Thanks for joining.